Okay, so chapter 5, we're still looking at probability. And today we're actually going to look at what we call conditional probability. Okay. So conditional probability is just when we focus on a portion of the sample space. So remember from last class what the sample space is. The sample space is just all the possible outcomes. And so today with conditional probability, we're just going to focus on part of it and not just the whole sample space. So let's look at some notation first. And for our notation, we see, or we'll write, probability of A with this vertical line and then B. So you'll notice we have two events here, event A and event B. And what this says right here is we have the probability of event A given that event B has already occurred. So we're looking at A knowing that B has already taken place. So here, event A is our interest. It's what we're actually trying to find the probability of. And event B is just like our restriction, what we call it. So B is just saying, okay, knowing that B is true, we're going to find the probability of A. Okay. So let's take a look at an example. We're going to use an example from last class. So I have my table already. And we'll take a look at this. So I have my table here. And this is the two-way table from last class, where I have the coffee drinkers and non-coffee drinkers. And I broke the class into the different year students you all are. And I have a total of 36 students. Okay. So for this example, we'll start with, we're gonna look at some conditional stuff here. So let's write it out and then we'll write the notation just like we did last class. So the probability of choosing or selecting a first-year student if they drink coffee. So I want to know, what is the probability of choosing a first-year student if they drink coffee? So here I have some keywords, and it's the word if here. So when we're looking at conditional probability, we don't have just one word like we did last class where it said or, and we knew that meant addition. Or if we had and, we knew that meant the multiplication rule. It's not like that for conditional probability. You might see if, you might see given, you might see out of, that kind of stuff, okay? So we just have to make sure we read this and then we get what we're trying to do. So I'm going to start with writing capital P for probability, and then in my parentheses, so this is my notation. Remember I want A given B. So A is what I'm interested in. It's what I want the probability. And right here it says probability of choosing a first year. That's what I'm looking for, right? That's what I'm interested in. So here I have my first year given, and given's just the vertical line. They are coffee drinkers. So I'm just gonna write given coffee. So what we're gonna do here for the two-way table, we're going to take the two-way table and we're first going to outline the restriction. And in this case, it is the coffee. It's the second part, coffee. It's the B event. So we're gonna outline that. So I'm gonna take my marker and I'm going to outline all of that here, okay? And secondly here, I'm going to shade what I'm interested in. And my interest is event A, which in this case is first year students. So I'm going to shade that. So here I'm just going to shade this one box in out of where I restricted it, out of the outline. Okay, so here I can say my probability of first year given coffee is going to equal the shaded regions added up, right? In this case, there's just one, divided by the outline. And we can see here the shaded is just 4, and the outline 4 plus 3 plus 1 plus 3 plus 1 is the 12 there because we have the total. Remember, like I mentioned last class, you don't have to reduce. You don't have to rewrite this as a decimal or a percentage. You can leave it like that. I want you to write it whatever form you want to write it in. So let's try another one. Slide this up here. So for a second one, let's find the probability of choosing a coffee drinker among the third year students. So here for my notation, I'm going to go ahead and put my capital P, and I want to write next what I'm interested in. So probability of choosing a coffee drinker. That's what I'm interested in. I don't want you to think it's always the first event that pops up. It depends on the wording. Among here. So among means I'm putting a restriction on. So out of the third year students, I want to know the probability of choosing a coffee drinker. So right there, like how I just worded it verbally, you can hear how the coffee drinker was the second event, but it's still what I'm interested in. It's still what I want to know the probability of choosing someone that is a coffee drinker, okay? So it's not always the first one, it's just how it's worded. And among here means out of, or given that they're third year students, I want to know the probability of picking a coffee drinker. That's what I'm looking at. So given third year. So that's the trickiest part of this type of probability, is picking out which one's my interest and picking out which one is my condition or my restriction. Okay. So let me erase that one. So let's go ahead and put the restriction on there, which is third year student. So I'm going to outline that here. And now I want to shade in what I'm interested in, which is coffee drinkers. So I'm going to shade in the one box out of the outline because that's all I have, because I'm just looking at the coffee drinkers. So here I can see my numerators is shaded, which is 1 out of the total 1 plus 8, which gives me 9. Okay, so it's the total of the outlined region. Okay, so that's using the two-way tables for finding the probabilities without formulas. It's just using the two-way tables and the shading. Okay. Like I mentioned before, you may use two-way tables or you may use formulas. When we're going to look at formulas here in a minute. When we're looking at the formulas today, we're actually going to use the data out of the two-way table to pull it from to use the formulas. And it's going to look similar. You have to keep in mind when we're doing conditional probability or even like the multiplication rule we're going to talk about today, you have to be given enough information to actually complete the problem. So like the example I gave you, which was like a word problem, the very first one last class, where I just said we had 36 students, 12 coffee drinkers, 24 non-coffee drinkers. There wasn't enough information to compute all sorts of probabilities, right? Because first of all, I didn't give you this information by breaking the class out by year level. Each student was. I didn't have that. So I only could do so much with that little bit of information. So keep that in mind. You must be given enough information to calculate all of these probabilities. So let's take a look at some formulas. I'm going to pull this back up here in a minute when we need it and we do an example. For formulas. So I'm going to start where we left off last class. That was with the multiplication rule. So that's where we're looking at the probability of A and B. And remember, like we just mentioned, this is my multiplication rule. And with that multiplication rule, we had a special case, which we talked about last class. So when I'm going to write this form, it's probability of A and B, which equals probability of A with the intersection of B, right? This upside down U means and. And for the special case, it was just the probability of A times the probability of B. That was a special case. And we said that they had to be independent, meaning that if A already occurred, we didn't want it to affect B, right? So we didn't want it to change the probability of B on its own. So it was just probability of A times probability of B. Now today we're going to look at the general rule, which of course we can always use the general rule. And this says that the probability of A times the probability of B, given that A has already occurred, is going to be my formula here. So if A is independent from B or vice versa, they're both just independent from one another, then probability of B given A will just be the probability of B. So it will go back to that special case. So don't think you have to know which one to use. You can always use this general rule. Same for the addition rule as well. This is my general rule. So A and B are not independent. And if they are, it's okay, it will work out all right. Okay. If A and B are not independent, then the probability of B given A is just equal to the probability of B. And I already said that verbally, but what I'm just saying here is that if A and B are independent, A doesn't affect B. So probability of B, knowing that A's occurred, is just gonna be the probability of B because A doesn't affect it, okay? So, which would be probability of A times probability of B. That would be my special case. So that's my multiplication rule, going from last class. Now let's talk about the conditional probability. So this is the probability of A given B. So probability of A given that B has occurred. So this is my conditional probability. So here, like we already talked about the notation, probability of A with a vertical line B just says A given B here. And this formula is going to be this multiplication rule just moved around. So this here is going to be the probability of A and B divided by the probability of B. When you divide by the probability of just one of them, it's not whichever one you choose, it's always by the second one, by the restriction here. Okay, so up here you can see I had A and B interchanged. So that's why it would be the A and the denominator on that one. So it's the same formula, just moved around. So some people get really confused because then you keep going back to algebra, right? Well, how can I plug that in? It's just going to keep going around in circles. You're right. It's not how it works. You have to be given a certain amount of information to do the probabilities. And that's what I was saying before. So you would have to be given like this, or I'm going to show you with the table how we're going to pull the information out to get this. Okay, we'll pull that out. All right, so let's take a look at an example. I believe I have 2 examples, so one of each, using the formulas. But again, we're going back to the table because that's where my data is. It's where all my information is. So let me grab my sheet here with my table. Move some of my stuff around. There we go. Okay, so for example, the first one we're going to look at, I'm just going to write my notation. I wasn't going to write it out in words. I hope that's okay with you guys. But I want to look at the probability of a 4th-year student and a non-coffee drinker. So right here, this is an and. When I'm looking at an and problem, so here, the intersection, remember that's the overlap. It's where the 2 come together, right? The 4th year and the non-coffee, it's where they're both there. And in order to use the special case, I need them to be independent. I don't know. I'm going to ask myself, are these independent? I'm not sure, right? That's going to happen sometimes. We're going to just say, we're not sure if these are independent or not. If we're not sure, then just go ahead and use the general rule, right? We can always use the general rule. So let's just go ahead and use it because we're not sure. So I'm going to take a look here. I'm going to write this all out. So the probability of a 4th, I'm going to abbreviate a little bit so I have some room, and a non-coffee. So looking at my and, I'm going to use my general rule. So this is the probability of the 4th, that's the first one, times the probability of the second one, right? The non-coffee, given that 4th, it's already there, right? Knowing that's a 4th year. Okay, so we're going to use the table to pull out our information. We're not going to do shading and outlining and all that stuff because I'm not using the table in that way. I'm just using it to get the numbers. What's the probability of just choosing a 4th-year student? Well, right here I have my 4th year. My total is 5 out of 36 students. So that's just kind of like what we did last class. And I apologize, you can't see that. There we go. And next, I want to know the probability of choosing a non-coffee drinker among the 4th, or given the 4th, or out of the 4th, okay? So I have all my 4th-year students, and I want to know the probability of them being a non-coffee drinker. So I'm looking at my 4th-year column. My non-coffee right here is 2. And it's not out of 36. It's out of all the 4th year, so it's just out of 5. You can see my 5s would cancel, and this is just 2 out of 36. Or you can write it out as 1 out of 18, or as a decimal, percentage, however you want to write it, okay? So that's using the formula with the information out of the table. Let's take a look at another one. Here I want to know the probability of choosing a third-year student given that they're a non-coffee drinker. So I want to use my formula. So here my formula says I'm going to look at the probability of a third-year student and non-coffee divided by the probability of them being non-coffee. So when I have division, I can see that, and I have probabilities. I'm going to have a fraction in my numerator, and then I'm going to have a fraction in my denominator, and that's okay. We're just going to take it step by step and try to go back to algebra and remember. So probability of third year and non-coffee. So remember, this is the overlap. So this is where the two come together. So third year and non-coffee. So right here, I'm looking at 8, right? Out of the total of 36. So that's my numerator, 8 out of 36. And it's divided by the probability of just a non-coffee. Well, my non-coffee, I have 24 out of 36. I'm just pulling the information out. I'm not using any shading. Now when I'm doing this, I have to go back to algebra class and remember how I handle this. I'm going to keep my first fraction, the top fraction, the same as it is, 8 out of 36. I'm going to change this division to multiplication, and I'm going to flip this bottom fraction, and so I'm multiplying. So it'll be 36 over 24 now. And the 36's will cancel, and I'm left with 8 out of 24 here. And that's how we're going to use the formulas given the information in the table. Because remember, like I said, I'm always going to give you the table. You have no pressure to use one way or another. You could choose whichever way you want for this, calculating these probabilities.